Okay. Hi, everyone. My name is Melissa Potvin. We're going to get started now. I am a community manager here at CA. I am filling in for Kristen Palazzolo, also a community manager here at CA. You're probably more familiar with her. So we have a great presentation lined up for you today. Just a couple logistics I'll go over with you first before I pass the ball over to Matt McClarty. All lines have been placed on mute at entry of the call, so #6 to unmute at the end. We will open up for Q&A at the end of today's presentation. You can also, during the presentation today, ask questions. You can use the chat window or you can use the Q&A panel, which is on the right side of your WebEx screen. So you can ask questions either way. We'll open up at the end for questions. I'll remind you how to unmute at the end of the presentation. Just so you know, the event is being recorded. We do publish the recording into the community. If not by end of day today, then definitely by tomorrow. Again, my name is Melissa. You could shout out to me if you have any questions or if you have any concerns. You could send me a chat. I'm going to pass the presentation now over to you, Matt. Matt, the floor is yours. Thank you.
Thank you very much, and thanks everyone for joining. I'm very happy to be here in Vancouver, sunny Vancouver, with Darren Solomon. Darren, how's it going?
It is excellent, thank you.
Good. Darren's here in Canada drinking a Tim Hortons coffee, so we're very much acclimatized to our environment. Anyway, wherever you may be, we really appreciate your attendance. We're going to talk today about microservices, microservice architecture, and particularly the role of API gateways within a microservice architecture. So we'll just start off with a little run through, kind of an overview of what microservices are all about, the role of APIs within microservices, and then we'll dive into the role of API gateways, and then Darren is actually going to do a live demo of positioning the API gateway and where it fits within a microservice architecture, which really is the interesting stuff here. So I'll try and rush through my material. But just off the top, there's a Q&A box on the WebEx, so if you have any questions as we go through, we'll take questions at the end, but please feel free to post questions at any time and we'll be happy to answer them at the end. Anyway, let's jump right in. So, microservices are a really hot topic. They're a thing. This has been, I guess it was about February 2014 that Martin Fowler and James Lewis published the now ubiquitous blog post describing what microservices are all about. Since then, we had Sam Newman's book come out a year later, and there was just explosive popularity of microservices. And let's face it, microservices and what they're all about is being tagged onto just about everything going on in technology these days because it's a very wide-ranging movement. In fact, it's hard to even describe what it is. Is it an architecture? Is it an application style? Or is it a movement? I think it's really all of those things. But really, it's kind of the culmination of the whole Agile progression from Agile through to continuous delivery, DevOps. It's really the architectural style that fits that mentality of building software systems. But some characteristics of microservices that are straight from the Fowler-Lewis post, unbundled services. There's different terms for this. I like unbundled. Some people say decomposed. That just kind of gives a visual image of what you throw with. But anyway, it's all about breaking down large, complex systems into smaller, discrete services that still function together as a whole. Bounded context is this concept that comes from Eric Evans' domain-driven design, which is a way of understanding data boundaries and service boundaries. It's quite helpful. An example, if you think about a customer is a very broad concept, but if you think about the different contexts in which you'd understand a customer, whether it's from a salesperson's perspective or a CSR's perspective servicing that customer, there's all sorts of different perspectives. And so this notion of bounded context helps to break down into services. Of course, important to this discussion is that typically microservices are exposed through APIs, predominantly RESTful APIs and HTTP-based APIs, and I think that's really organic based on how the paradigm of development around APIs has grown up. But there's also popularity of interconnecting microservices through message-based asynchronous protocols as well. A big goal of microservices, a big benefit comes from microservices when you're able to minimize dependencies between the services. That's really the art versus the science. When you can structure your system in a way that you've got relative autonomy between the different services. And it's important to note that once you have all these microservices, it's very unlikely that you're going to be just using a particular service in isolation. Really, they blend together to form the bigger applications or systems. And it's quite helpful and actually historical that microservices have always been defined in opposition to monolithic applications. So this concept of a big monolithic application that has to be deployed as a very large chunk can be very brittle when you're making changes to it. That's the distinction that we make when we talk about microservices and the advantages they bring. So, I run a team called the API Academy here for CA Technologies, and we actually had a great opportunity in the last few months to write and publish a book on microservice architecture that's now available. We actually have it, thanks to CA, it's been sponsored as a free download. So if you go to the link below, you can get the book as a free ebook. It really gives a comprehensive view of microservices, microservice architecture, the value they bring, and a lot of the culture and practices that go along with that. But we tried valiantly to come up with a one-sentence definition of microservices, and we could get as far as writing it down in two, because there are really two important perspectives when you're looking at microservices. First of all is each service itself. A microservice itself has characteristics. It's independently deployable. It has a bounded scope. Its goal is to focus on interoperability, and communication happens with messages as opposed to other maybe UI-centric means, but really the essence of the microservice is to be message-based. But maybe even more importantly, that is how those microservices fit together. So we use the term microservice architecture to talk about that. But this is really the style of engineering systems that are highly automated, that are evolvable, so they're built to evolve over time. They're built to handle lots of dynamic change. And they have alignment with specific capabilities. Those could be business capabilities, those could be technological capabilities. But, this is really our aggregate definition of microservices, microservice architecture. And, maybe a better way to define microservices is not so much to get pedantic about the definition, because that's a pretty easy thing to do. Like, the way microservices evolved, it wasn't like somebody was in a lab somewhere and mixed a formula together and came up with microservices. This is really something that grew out of a number of grassroots stories about how different influential companies were building their systems. Probably first was Amazon. There's a great link here that goes back 10 years, an interview with Werner Vogels for ACMQ, where he's describing the way Amazon systems work. And he uses the term service orientation. But really, if you look at the quote here, talking about scaling operations independently and at the same time getting strong availability and introducing new services quickly, this really boils down to the essence of microservices, and certainly it's the style that Amazon has used in building systems. Maybe even more vocally, more well-known for their microservice implementation is Netflix. And really, Netflix has a unique set of challenges around scaling. I think they constitute some double-digit percentage of the internet traffic in the world with the content that they're streaming. So, their scalability needs go beyond pretty much any other web-based company. But this is really the approach they're using of taking microservices, much more independently deployable units, and putting a big operational focus around those to build resiliency and scalability into their environment. There's also Adrian Treneman here, who was great. It was great we had him as a guest panelist at an event we ran in New York City recently, talking about what Guilt has done, which is now part of HPC Digital. For HPC Digital, it was really about removing dependencies between teams. They really wanted to just make sure that they could get new features, new code out into production. And so they built an organization and an architecture that would help support that, and the resulting architecture is what we would call microservices. Similarly, Phil Calcido of SoundCloud, I think it was SoundCloud at the time, there's a great article here talking about how they ended up doing microservices, and it was very organic. It came from, removing a series of bottlenecks. First, how do we build teams that can build code faster? Then how do we deploy faster? And then ultimately, how do we have systems that can evolve faster? And that's how they came to microservices. So we see a common set of principles and a common set of goals around here, and we boil it down very simplistically to the following, which is the goal of microservices and microservice architecture is to achieve a harmony of speed and safety at scale. So I think it's fair to say that there are different approaches out there for developing software quickly. Certainly that's the goal of Agile to help do that. And similarly, the goal of Agile is to actually build higher quality systems, so in that sense, much more safer resulting systems. The challenge that we've seen a lot of companies come with is as they try and move towards that higher level of agility in their software development, though, is as systems scaled up, things just slowed down because they had all these system issues to deal with. And so microservice architecture is really what enables that speed and safety to continue as systems scale up. A monolithic architecture is something that is kind of a default for people. They start out building systems as a monolith. As the scale increases, they find that the complexity of the system begins to outweigh the advantages of going with a single unit of deployment on the whole application. And that's where you need to break things down. So that's kind of the overall context of microservices. And an important thing to recognize here is that those system aspects and where the complexity resides in the architecture. And a monolithic system, you know, a lot of the complexity can be hidden at a low scale, but all of that complexity just becomes much greater and more of a burden to developers as the scale increases. Whereas with a microservice architecture, the complexity moves away from the developer, moves more towards the maintainers of the system. And when you're dealing with system aspects, if you're in a microservice architecture, it allows you to automate a lot of those complex functions, which helps you deal with that complexity in a more reasonable way. So here are some, again, from the Fowler-Lewis sort of canonical definition, some of the attributes of microservices. It's about componentization. It's about business capabilities. We kind of talked about that. Products, not projects, so this idea of long-living resulting products as opposed to temporary projects to build things. There's a concept of smart endpoints and dumb pipes, so having more functionality live within the service itself. This is an important consideration. We talk about gateways later on. And then this notion of decentralization, where you're now, instead of having a command and control top-down approach, you want to be able to disperse and empower individual and independent teams, as well as dealing with decentralized data. Automation I've talked about a lot. Designing for failure is a really key aspect of building these microservice systems. You want to make sure that, as opposed to being afraid to change anything, you want to get really good at change and make sure that when you make changes, even if things break, you're not going to destroy the whole system. And then evolutionary design is fundamental because this is all about recognizing that when you deliver a certain release of software or a certain solution, it's going to change. Much of the development work is going to happen after it's deployed as a system than before it's actually deployed the first time. But another attribute that wasn't mentioned explicitly in this way, in that definition, is something that you can't ignore, which is microservices has risen in parallel with the rise of containers and Docker. And I think there's a tendency for companies, individuals to we're technologists. So we just have a tendency to love technology and wrap ourselves around the axle of technology. So I've talked to many companies who are talking about doing microservices, and their exclusive focus is on Docker. And you know, to them, building microservices is about Dockerizing their applications. And there is no doubt that there are some huge benefits that you can gain from using containers in a microservice architecture. And in fact, my co-author and former API Academy member, Irakli Nadarashvili, likes to call containers the gateway drug for microservices. But I think there's certainly lots of ways that you could just use containers and not end up with the benefits of microservices, because you really need all these other attributes in order to be successful. But of course, another big common attribute is APIs. And APIs, I would argue, are even more fundamental to microservices than containers. because you can do microservices without containers, but you can't really do microservices without APIs. And there's reasons for that. Like, APIs are fundamental for microservices because they cover a lot of different aspects that both provide the benefits of microservices that we've talked about, as well as move you towards the benefits of microservices. So, introducing an API-first system, even if it's a monolith, is a great stepping stone towards microservices. And here are some reasons why. First of all, when you express APIs, and we've got great languages, resources, frameworks now that help describe APIs in a very automated way. APIs give you a technological way of expressing the business capabilities of microservices. This really can serve as a bridge from the business to the technology. So if you're talking about your system, if you come up with a set of definitions around what APIs are available for your microservices, it's actually an understandable way for business people to see what those services do. It'd be hard to hand somebody in the business a container and try and explain, this is what this is all about. It's a great way to describe the actual business capabilities through your APIs. Also, domain-driven design, which I mentioned earlier, is a popular approach to modeling microservices. Now, domain-driven design was actually an object-oriented thing that is, I would say some of the higher-level aspects of it are becoming more popularized again for microservices. But when you're modeling systems through domain-driven design, that's where you get into domains and bounded contexts and maps of those contexts, and then the interfaces. There's a really nice synergy between how you would build APIs and then how you would actually plug into the other aspects of domain-driven design. It really provides you a consumable means of understanding the system. So when you're dealing with systems, the systems theory will teach you that if you try and understand every detail of the system, it's incomprehensible. You need levels of abstraction in order to understand systems. You need to hide information in order to understand systems. And so APIs provide that. It doesn't matter what's behind the API, as long as the API is provided in the way it's described. It gives you a nice level of abstraction for understanding your overall system. And really it becomes a normalized access point for system functions. So when you have an API for your service, you have the opportunity to place your security enforcement, to compose services, to monitor services, to collect data about activity and SLAs and documentation and so on. There's a lot of value in APIs for microservices. Now this is a bit of an eye chart that I collaborated on to describe, this is not going to be every company's microservice capability needs, but this is pretty much a laundry list of all the different capabilities that you may require when you're adopting a microservice architecture. And we can certainly see in the box labeled the mediation capabilities there, a number of those system properties that I just talked about. So let's talk about API gateways for microservices. So if you have APIs in your microservice system, which you should, and how do you take advantage of that opportunity to get at some of those system properties we talked about? So once again, with domain-driven design, when you're dealing with these complex systems and cross-domain communication, there's the notion of an anti-corruption layer. This actually maps pretty nicely to what an API gateway can provide, which is a way, kind of a translation point for the domain understandings to actually commingle and communicate. API gateways, in spite of all us companies that provide API gateways, the need for API gateways is actually something that's been popularized by many who are thought leaders in the microservices space. So Sam Newman in his Building Microservices book, great book, talks about the need for an API gateway. And he has this concept of backends for front ends. I've got a picture of it and a link on the right-hand side here. Also, Chris Richardson, who runs Microservices.io and actually is quite a thought leader around microservices. He's got patterns for API gateways, and Darren's going to talk a bit more about that picture. But there are key capabilities here that can actually take advantage of the APIs in a microservice architecture that can really help you deal with system complexity. Dynamic routing and resiliency. So microservice environments have a lot of ephemeral components. How do you route to those? How do you discover them and actually discover when they're not there? Aggregating services. So how do you, if you've got and this is a big part of the backend for front end that Newman talks about, if you've got a mobile client or some client system that doesn't want to be as chatty in communication, but requires multiple services, how do you solve that problem? Well, you can aggregate those services in a gateway. Policy enforcement. So an example would be OAuth, token validation. There are other types of security policies you may want to enforce, JSON web token and so on. You can deal with that in a gateway layer without having to have every service developer build that functionality into their service. And even just collecting data for monitoring, as well as managing service levels, doing things like rate limiting based on identity or based on requesting application. So there's a lot of capabilities that just make sense at an infrastructure layer. And in spite of that smart endpoints for dumb pipes principle that was done earlier on, all the companies that we're talking about microservices and deploying microservices all have this notion of a shared set of capabilities that just make sense to be maybe not centralized in deployment, but certainly centralized in creation of policies and then dispersed out into their environments. Netflix has their own gateway component that they built in. Many other, you're aware of the Amazon commercializing their API gateway. So there's lots of validation for the need for an API gateway. So at this point, I'd like to hand it over to Darren to talk a bit more about where the API gateway fits, as well as give you a hands-on example.
Awesome. Thanks, Matt. Every time I sit with you, I learn something new. This time I've learned when Matt McCarty's opening, don't follow, because it's like following the Beatles. I don't know. Actually, I'm in Canada, so maybe I should have said it's following Justin Bieber.
Oh, no, come on.
And he's a musician, too, so I know I just compared John Lennon and Justin Bieber, so I think I'm not going to get a free copy of it.
Rush, maybe?
Maybe, Bernie, maybe, I'm not sure. So thank you for that introduction. I'm just by way of introduction, I'm Senior Principal Consultant for the API Management Business Unit as part of TA, which is just kind of corporate speak for I'm a tech guy. I think a lot about API management. I think a lot about building APIs and implementing security and identity brokering and all of the different things that you would expect APIs and API management to do. The best part of my job, though, is when something new comes out. I get to look at it with a critical eye and say, does my domain fit into this space? Is it interesting? Several months ago, Mr. McCarty and his API management team, the API Academy team, started talking about microservices, and I walked in with a skeptical eye and saying, well, what is this thing? Is this an evolution of SOA? I think I've heard this story before. What is this thing? So I started to learn everything I could. I started trying everything I could, and I spent months and months and months, getting my hands and my feet wet, trying to understand how API management may fit into this thing called microservices, which are enabled, as Matt was alluding to, by APIs in general. So I spent a lot of months. Fast forward to about a week ago, and they were talking about this webcast, and they said, hey, Darren, can you come and talk to people about API gateways and how to secure their APIs and how to, transform their businesses and help do all those things? I said, sure, I'll come talk about it. It'll take about 3 minutes because I have no idea how to do that. So I hung up the phone. About 3 minutes later, my boss called me and said, hey, Darren, what have we been paying you for the last 6 months? And to that I responded, I have no idea about that either. But the truth of the matter is, it's not about how to do it. I can't prescribe it. But what I can tell you is I talk to a lot of people. I talk to a lot of people in the industry. I talk to a lot of people that are my customers. And there's some patterns that are emerging. So it's not that I can tell you and prescribe to you how to secure your microservices, because everybody's somewhere different along this journey. Some people are trying to transform their business from legacy architectures to modern architectures. Some people are trying to enable a mobile initiative. Some people are trying to just get to market faster with new greenfield services. but it all boils down to one fundamental truth, and this is sort of the point on the horizon. Everybody is trying to improve or increase their velocity of getting to market faster with the services that they're offering. So what does that improvement in velocity mean as far as technology? Well, for the most part, and Matt touched on it, it's about automation. It's about zero touch. It's about continuous integration and continuous delivery. It's about giving control back to the people that can actually accelerate the delivery of services, the developers. So with that, I'm going to try to do a little bit of a demo for you. But if I'm true to my word and it's all about automation and headlessness, the goal of this demo is to be the absolute most boring demo ever presented on a webinar ever, because really theoretically I should be doing nothing. So I'm going to try to get to that point as fast as I can. So let me just show you the scenario architecture. I have essentially a Docker environment. We talk about how containers may enable microservices. In the case for this scenario, I am using Docker. You'll see, on the left side here is just most of the things that the experiences that you want to create for your partners, for your applications, for your clients, whatever it happens to be. It comes into the ecosystem. It's a microservices ecosystem. I will be deploying a gateway, and I have an empty system right now, so everything is under source control right now. So it's trying to make it as realistic as humanly possible. We've got a gateway. I've got the Netflix OSS stack, so I've got pieces of that Hystrix. I've got Eureka. I've got a bunch of different things behind that. I've got CA Live API Creator, which is going to help me enable my orchestration scenario, which I'll talk to you a little bit about. But essentially, it's taking an orchestration and then putting it to a dynamically generated API in front of a data source. And then I've got a whole bunch of microservices behind that. So I've got a config microservice, a discovery microservice. I've got a bunch of hello microservices that I'll walk through a scenario with you. I've got a users and an orders microservice. Essentially, the scenario for an orchestration, I have users, I have orders, and maybe I want to create, some sort of shipping list. So those are all the different things. So with that, the first thing I'm going to do is I'm actually going to deploy everything. So you can just see it live. It takes about 3 minutes, so I'm just going to start it, and then I'll explain to you some of the things that I'm doing. So if you look here under my source control, and this can be anywhere, I've got my config microservice, the discovery microservice, everything that you're talking about, or everything I already talked about. Oh, I'm sorry, let me show my screen. I don't think I'm showing my screen yet. Give me 1 second. Sorry about that. Show my desktop. All right, can you guys see my screen now? All right, fantastic. So this is just my source control system, everything that I was just describing before, my config microservice discovery. I've got my compose files. I've got my hello applications or microservices. I've got my LAC. I've got a bunch of the Simian army here, too, to use Netflix's term. I've got a run monkey. I've got a fix monkey somewhere. So in essence, to run monkey is basically going to run a Maven build. So that's the first thing I'm going to do. It takes about 3 minutes. It uses Spring. It ultimately will build all of my things. So going back to my web, I'll just do it off of my own presentation here because it might be easier just to go back and forth. The scenario architecture is there. So here's the scenario walkthrough. I've got a Maven Docker build with a Spring Boot, including a config and discovery microservices, a bunch of hello microservices, users and orders, which I've described. I'm deploying SSG, Live API Creator, and MySQL. That's going to be the data source that Live API Creator will then front to create a dynamic API for me that I can actually put some data to and enforce some logic. And then I have a policy that I wrote, and I'll talk to you a little bit about the CA API Gateway policy language, but I have a policy that I'll deploy to my gateway that'll do a couple of different things. It does a domain-driven design orchestration because my users have a ubiquitous, a language to themselves. My orders have another language. They're within their own domains, but what I'll do is I'll orchestrate them because I have a business need, for example, of taking both of those pieces of information and then maybe making a shipping label, for example. And then I have microservices that I'll persist through a Live API Creator API data store. Here's my, just a screenshot of my policy manager, and here's my source control. So these are the patterns that I'm going to try to show you. There's a couple of different places you can put an API gateway, and gateways sometimes are the wrong word. because gateway sometimes implies that it sits only on the edge. It sits in a couple of different places, or it could. The customers and the people that I talk to are doing lots of different things. So I wanted to show you the two emerging patterns that I, for the most part, see. On the edge, where you put an API gateway between your customers or your clients and your applications, typical use cases that you might see there are things like threat protection, protection against denial of service, protection against SQL scripting, injection attacks, against message replay. You'll do dynamic routing. Hey, there's all these microservices that exist out in the world. How do I know where they are? How do I discover them? How do I send my clients that are making calls externally into my ecosystem of these ephemeral microservices that who knows where they are and what they're doing? And then you might do some transformation. So, some of my partners or whatever, some of my customers might be trying to consume a particular microservice or a particular orchestrated microservice, for example, in a certain format or with a certain identity or with a certain message type or a certain protocol. How do I transform what I have to what they need? So those are kind of on the edge use cases that I see. And then in between, if you were to take an API management solution and put it in between a couple of microservices, what are some of the things you might see? You might see things like security between microservices. You might see things like identity brokering between microservices. You might see things like protocol transformation between microservices. And the reason why you start to see those things is something that Matt alluded to. There's this whole idea of developer empowerment, the idea that they're sort of their own entity and they can build to their own stacks. Well, if you start to let them build to their own stacks and give them this polyglot development idea or ideology that allows them to get the velocity that they need to go to the market faster with services, well, now you've got maybe inconsistencies in the technology stacks that they use or the message formats or whatever they might use, but at the end, these microservices still need to communicate with one another. So maybe in between we'll use some of those ideas. So with that, there is something that's missing. So you have an API management solution in the middle of your microservices architecture. How does it know what lives where and what those capabilities or services that those things offer are? In the left side of the screen, you'll see there's really just the idea that you have a service client and a whole bunch of microservices, and you have a problem because how do you get your service client to your microservice? The solution happens to be a service registry. So if you see this link at the bottom, NGINX talks about this. I took this picture from them. They implement a service registry where all microservices will register with the service registry, and the clients can then speak to the service registry to understand where their microservices live. In the same respect, an API management solution can talk to that same registry to start to understand where everything lives and what they're doing. So that's exactly what we do in the solution here. So let me see if everything came back up. Everything is up and running. Let me show you. Let's pull up a new screen just so you can see. So here is my deployed everything. You'll see I've got an API gateway, I've got the users, I've got a bunch of hello services, I've got a config microservice, I've got a discovery microservice. Everything is now registered with Eureka in my case. So if I were to show you my Eureka now, you'll see that I've got a bunch of hello services. I've got my config server and my order details service. They're sitting on this port. These are just reflecting on everything that's going on here. Now that I've got this ecosystem, now I want to implement some of these things that I've talked about. I want to do dynamic routing. I want to do dynamic transformations. I want to do threat protection. I want to do all those sorts of things. What I have is in my case, the CA API Management Gateway here. This is just the client. You can do this all headlessly. I want to show you what the power of this tool. So I didn't do this last part headlessly, but I will show you the piece of it so it makes a little bit more sense. I'm just connecting up to that gateway, and I'm going to deploy a policy because this is now part of my ecosystem. And I will explain to you what this will look like. I'm just going to call it the microservice gateway or whatever, and I'm going to let it resolve to star, and I'm going to click finish. This is where I would actually design some of the policy that I want to do. I can do all of this headlessly, like I said, but I will import a policy that I already have, that I wrote just for the benefit of this meeting today. It is this microservices policy, and I'm going to save and activate it. If I were to show the comments, I'll show you there's a couple of scenario walkthroughs that I described. Here's a scenario for orchestration. Here's a scenario for dynamic routing. I create policies by pulling what we call assertions from this palette of assertions here. So if I were to expand this, this is my development window. I'm starting to, in this case, I'm talking to Eureka. This is the line. I route my call to Eureka. I find out where things exist. I ask them whether or not they're up. I create a routing strategy, and in this case, I'm going to do a round-robin routing strategy against all of my hello services. In this scenario for orchestration, I'm doing a very similar thing. I'm taking a bunch of calls to my users microservice, my orders microservice. I'm consolidating and creating a new payload. I'm ultimately going to drop that into an API that I dynamically created with LAC, the Live API Creator solution. So if I wanted to add threat protection, for example, I might go to my threat protection palette, and I will say things like limit message size, and I can drag that into the right side here, and then all of a sudden any call coming into this gateway will limit message size. So let me save and activate. This policy is now active in this ecosystem. Let me show you what that kind of looks like. I'm going to take a curl, for example. Let me do a curl. And so what something that Matt didn't mention, one of the patterns that are very much about microservices and it needs to be interacted with very simple tooling, things like curl. So that's what I'll do. I'm just going to take, and I'm going to send a header, and my policy is now saying if I send this header for the action header, for the hello header name, to the actual gateway, which is this, I am now going to send a call to my gateway. The gateway is going to determine by talking to Eureka what hello services are available, and it's going to dynamically route me to one of them. So if I hit enter, the response is this. I have 4 available routes. These are the IP addresses of the routes. Here's the latency of those routes, and here's my HTTP response code. So if I do it again, I should get a new selection. This is the route I selected the first time. This is the route I selected the second time. So if I do it again, and I remember I mentioned I was using round robin, so it's going to go round robin. Now let's take it, let's do it in a loop here. I'm just going to take that same call. I'm going to do a quick sweep in between them, and now you'll see I have 4 available routes. It's now round-robining against those routes, and here's the latency of taking each of those routes. Now imagine for a second, I told you I had a Simian army. So if I were to do the chaos monkey is actually going to select randomly one of those routes, and it's going to kill it, and we'll see how it responds. Remember, my gateway is now talking to Eureka to figure out exactly what's going on. All of my services are talking to Eureka to figure out what's going on. Here's Chaos Monkey. I'm going to kill it. It takes sometimes up to 30 seconds, but you'll see that I have 4 available routes. These are available routes. The Chaos Monkey is now killed one of them randomly, and you'll see that it's starting to slow down a little bit. I've got a latency of about 3 seconds because it's trying to get somewhere that doesn't exist before it moves on. Within 30 seconds, it will, you'll see it change. So I'll let that just happen. Of course, it's the last 30 seconds. I'm at the beginning of my 30-second window. I told you this was going to be the most boring demo ever.
I'm riveted.
Are you riveted?
Chaos reigns.
Yeah, well, it's going to happen. Come on, Chaos Monkey. Do your thing. He's coming. I'm sure he's coming. Thinking about it.
Yeah, and then maybe what we're looking at, I mean, this is awesome. You've integrated with the Netflix OSS stack. Service discovery and service registries are becoming really popular. People are using Console quite a bit from HashiCorp. They're using, we actually did a demo at CA World last year showing the interoperability with Console. Also, etcd, kind of CoreOS thing is popular, so there's lots of solutions in the space.
I just hung my macros. Let me do it again just to prove so you'll see it's now round robining. My latency is back to normal. Let me just do another Chaos Monkey real quick.
3 routes there now.
Yeah, now I have 3 routes. It'll click. I don't know if my while loop just hung for whatever reason. There we go, 2 routes. Now it's just round robining between those. Here's my whatever. So I also have the same thing on me for fix monkey. So I'm going to fix both of those that just broke, and you'll see that it comes back. And what this is doing is it's actually screen scraping at the same time. Let me pull this up. It's screen scraping here. If you go to Eureka Apps, it's actually pulling out, looking for all of the ups. It's pulling out that route, and it's deciding where to route it to based on the round robin. Okay, so it returned. So I had 2, I fixed monkey twice, and now I have 4 back. Now, I talked about one of the patterns that we have also is for threat protection. So what happens if I take this sleep away? And I just say it's like a sleep of 0. If you look back in the policy, I had defined a threat protection at the very top. I basically said I'm only allowing 100 per minute. I had a sleep of 1 second before. That means at maximum I was doing 60 calls per minute. Now I have a sleep of 0. I'm just going to let it fly. You'll see it's still round robining it until I hit 100 for that minute. Now I've exceeded my quota. But if I go back to 1, eventually it will come back after that minute, and I've gone underneath the amount that I have requested. It'll come back and it'll allow me to do some of those routing. So what I kind of showed here is the dynamic routing to those hello services, but I also showed a little bit of threat protection. So that's a really good on-the-edge use case. But what if I have some things that are interesting for orchestration, for example? I have this order details about maybe some books somebody ordered, and I also have their zip code, and I want to create and drop a file on some system that will ultimately process, my shipping. So let me pull up just the responses to some of those microservices. I'm going to use SoapUI to do that. All right, so it's come back. So now I no longer have a threat. So it's allowing me to reroute, and you'll see it goes right back to round robin. So let me go into one of the things that I've orchestrated, as I described before, is CA Live API Creator with a MySQL backend. So I've got, if you're not familiar with Live API Creator, it's a tool that allows you to take, it does a lot of things, but it allows you to very, very quickly take data sources and create RESTful APIs in front of that. But then it'll allow you to do things like reactive logic and protections and authentication and fine-grained access controls and all kinds of great stuff. So if I were to look at the microservices that I have existing today, right now, I told you I had a users microservice. If I were to just do a quick get to it, I've got a bunch of books and a bunch of addresses or zip codes. If I have my orders microservice, for example, and I do an orders to it, I've got a bunch of email addresses and the book that they bought. So now what if I have a need to have a whole bunch of these things consolidated and orchestrated together? Well, I have an API that I quickly created with Live API Creator here. So we can actually look at that API. And this is a whole other topic all on its own, Live API Creator. This is an API that I created behind a data source that I had, and I did it dynamically. And if I look, there's currently nothing in my main shipping table, which is part of an API. I can look in Data Explorer, which is just a graphical way to view my data, and this is all dynamically created views, and I can customize all these views and create logic, but there's nothing here. Now, if I were to do the orchestration use case, which would be the same sort of, let me do it from here. Where did I have that? Curl. I'll just retype it. So, let me see, where was it? Did I have that called somewhere here? I had it back. Yeah, I'll just retype it. So curl minus W. So I told you before it was the action, different headers will require different policy activities. For the policy logic, I had the hello one, so now I'll do the orchestrate one. Now, what this is doing is now calling my gateway. It called both of those microservices. It grabbed it. It created a single payload of the consolidated payload from each of those domain microservices, and it created a JSON payload that I then sent to the RESTful API on LAC on, right here, let me go back to here for the scenario walkthrough. Call came in, I went to my gateway, I went to the Netflix registry, I learned where the users and the orders microservices were. I called those microservices here, I got the payload, and then I sent them to the data API that was created by CA Live API Creator. I dropped it into that data store. And if I were to look now back in Live API Creator, and I do a get on that same resource, now I see that I've gotten all of my payload here, including all the benefits that I would have in the Live API Creator. Automatic pagination, for example. So if you were to look at the very bottom here, I've got automatic pagination. I've got optimistic locking with these checksums. It's enforced logic against my payload to determine what I'm going to do and how I'm going to react to that. So all of my business logic is built behind this API within Live API Creator, which is a very, very simple way to rapidly create services. I can explore my data by looking inside of Data Explorer. I can see the relationships between my data, you know, the books, the email addresses of the people, where it's going, what they ordered, et cetera, et cetera. So in essence, and with one policy, with one Maven build, I was able to deploy all of those microservices with a headless deployment of my API gateway, with a headless deployment of my LAC, front-ending a data store, and then ultimately just creating this environment for a microservices API gateway ecosystem. So that's where I am. So let me go back to the slides for a second, and we can continue. Let's see, how do I get back to that now?
No, I can actually
get back.
Yeah.
All right, great.
Actually, be click me in the WebEx there.
Yeah.
So that was awesome, Darren. Thank you for taking it. That was probably a couple hours worth of demo explanation there that you packed into a short period of time, but I think it gives people a great jumping off place, and certainly can follow up if there are any more details that are looking more there. So, just to sum up, right, it's about speed and safety at scale. I think you saw in the demo the ability to automate very complex functions. Microservices with APIs being a common factor, you kind of get into API inception there as well, because when you're not only are you offering business services over APIs, but of course APIs are the way by which you're opening your services up to automation as well. So there's a whole management plane aspect of it. So APIs everywhere. So many of the capabilities that are relevant in microservice architecture. You've got runtime things to consider, design time things to consider, but API gateways definitely help out with a lot of these key system capabilities like routing, aggregation, policy enforcement, collecting data. And I think there's a whole other aspect of that in terms of how you can detect the activity that's happening on your APIs, roll that into operational systems, analytic systems, and really understand your environment as well as managing the service levels proactively. So we had a very condensed, dense amount of information here, lots of opportunity to branch out more on each of those topics. But at this point, I think we can take questions. So I'm looking. I don't think that we have any specific questions in the Q&A panel, but feel free if you want to post something there.
I did see one in the Q&A panel if you want to take that live. It's actually in the chat. It's in the chat window. But while you're looking at that, I just want to remind everyone, #6 to unmute your line. You sometimes have to hit that twice. So #6 to unmute if you want to ask Matt or Darren a live question. Just pause for a moment.
So yeah, I'll answer the, while people are, if they're in #6 to ask questions, I can answer that question. So the question is, how do you draw a line between microservices versus macro web services? And this is a good question because it's actually a major subject of debate around why is the term micro even part of microservices? When talking to companies, like, this is a great example of why not to get too pedantic about the definition. Really, microservices should be all about the benefits and goals. So it should be about what's going to help you achieve the speed that you need while maintaining the safety of the system as things scale up. For some companies, that will mean they have very small, discrete services. Maybe they have very complex environments, or they have very high volumes on particular aspects. Other companies will have very coarse-grained services as their microservices. They may not feel like microservices. But the point is, if you can achieve the reduction of dependencies, if you can achieve the autonomous deployment and facilitate automated deployment, and there's a real organizational aspect that I didn't get into deeply. We've got other talks that have been getting into depth around that. The real static number that we've seen for effective microservice environments doesn't have anything to do with the services themselves. It really comes down to the size of the team that's supporting them. So we found consistently that companies that are being successful with microservices have small, empowered teams who have responsibility for one or more microservices. Those teams are usually about 5 to 7 people. And so if that team is able to support a very coarse-grained service, then they can usually still get the benefits of microservices. As soon as that team starts to bend a little bit in their ability to support a particular service, if that service feels like a monolith to them, then that's when you split it up and assign responsibility to different teams. So that's one aspect of looking at micro versus macro. I think another way to look at it is certainly from a UI perspective, it's not like you would have a single UI for each microservice most of the time. In most cases, your UIs will be aligned with different user roles that you would have. If you've got consumer sites, as an example, if you go on the Amazon website and have that single portal of your home page, that could map to 100 to 200 different microservice calls in the back end. But that speaks more to the complexity of Amazon and the maturity of Amazon's microservice environment. So as a follow-up here, if you build service driven by domain-specific criteria, considering smaller payloads, it fetch more specific information. So that what you've just described there, if you have a set of services that, for the reasons I described, you've broken down into these smaller services, but you have a UI that requires multiple calls, and you can aggregate those calls, yes, the scenario that we're describing around aggregation would be what you would what you could use in that scenario. Where you can run into trouble in trying to use a gateway for aggregating services is if you actually have a lot of logic around the sequence in which the services are called, or if there's state that really needs to be held between calls. So if the result of a particular call is going to change which other services you call, if you get into that type of complex kind of workflow logic, then you probably want to have a separate service to do that. If you're just aggregating information, let's say for display in a mobile app, that's a good candidate use case for the aggregation that we were showing.
Did that answer the new question that just came in?
It sounds like we got a thumbs up from Nishikant and Rest.
Okay, yes, I see that. Great. Okay, let's just pause one more second for any live questions. #6 to unmute. Any live questions for Matt or Darren?
I hope that's because I had a really boring demo.
Well, the good thing is since there's no more questions, I think we can begin to close this out. Thank you for joining today. Thank you to Matt and Darren for your presentation. Thank you to the community for joining. This was, from what I understand, the third webcast in a series of Lunch and Learn webcasts. Kristen Palazzolo is your community manager. Make sure you're following her so you can stay close to any new events that she may publish to the community. I'd like to thank the community for taking time out of your day for joining us today. Of course, we did record, so you can check back into the community tomorrow. At the latest, we'll get this published, so you can hopefully share this information with colleagues and friends. That's it for today. You can continue the conversation if you think of any questions. You can ask a question in the community, and we'll make sure to get you any answers that you may need. So that's it for today. Thank you, and everyone have a wonderful day. Thank you.
Thank you.